Hello and welcome everyone to another session in the DataHour series. We are really very excited to be here with you this evening for such an adventurous session for learning with interaction. I'm Shresht Sahu, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. For those who have just joined us for the very first time, a brief introduction about the DataHour sessions. The DataHour is a series of sessions conducted by Analytics Vidhya, led by top industry experts. It is a very fun way to understand the concepts of data science from the leading players in the data tech domain. And the name suggests itself, it's 1 hour totally dedicated to data. And the guys who just joined us, please do interact into the poll. Now on to our today's session, which is for Convolution Neural Network for image recognition. In this session, we will be going through the following topics: artificial neural networks, activation functions, convolution neural network, steps to design deep convolution neural network model, and hands-on with CNN model implementation for image recognition. And an important note before we kick off things, I would like to tell you guys that we are recording the session and we will make the recording available in a few days on our YouTube channel, for which you will get the link in the chat section in a couple of minutes. Please use the Q&A section for asking any questions you might have during the session, and we will do our best to answer them as the data progresses towards the end. And last but not the least, we will share a feedback poll towards the end of the session, which I request you all to participate in. So, all right, now on to our speaker in this session of DataHour. We have Dr. Nitin Shelke with us. Dr. Nitin Arvind Shelke is an assistant professor at the School of Computer Science Engineering and Technology, Bennett University, Greater Noida. He has extensive work experience in research, teaching, corporate training, and as a consultant data scientist with multiple organizations in the past. He has also received a PhD in computer science and engineering. That's a really fascinating profile, I guess. So over to you, Nitin. The virtual stage is all yours.
Yeah, thank you. Hello. Hello, I'm audible?
Yeah, you're audible. Just a second.
Yeah. So good evening, all of you. Let me share my screen. I hope my screen is visible.
Yes, it is.
Okay. So my name is Nitin Shelke, and the session is based on the deep convolution neural network or image recognition. So these are the outlines that we are going to cover. So as we know, CNN, if you would like to understand the CNN, we should require the basic understanding of artificial neural network, terminologies used in the neural network. And then after that, we are going to discuss the convolution neural network and how to design the CNN model. And at the end, we will take one hands-on that will be useful for all of you for doing the image recognition. So let us start with the artificial neural network. So what it exactly means, the term is artificial neural network is basically inspired from biological neural network. That means it is a human brain. The purpose of human brain, we all of you know that it is useful for solving the problem. Okay. The same kind of thing we want to create it artificially. Okay. We want to mimic the structure of human brain, and we want to add some we want to add some intelligence in that. And that structure is called as artificial neural network. So artificial neural network is in the field of AI where it attempts to mimic the networks of neuron make up a human brain. So brain means the set of neurons interconnected with each other. Okay. So that the computer will have an option to understand the thing and make the decision in human-like manner. Okay, so basically the entire purpose of this thing is to solve the problem, real world problem. Okay, and we wanted to automated things. Okay, like we know that we have a limited set of medical practitioner. Okay, so we wanted to replace the medical practitioner by machine, okay, or artificial brain that can take the decision, means what with what disease the person is suffered. Okay, so like that. So as I told you, so artificial neural network means it is a kind of the copy of human brain. Okay, so these are the terminologies that we have: biological neural network versus artificial neural networks. Okay, so in brain, all the neurons are interconnected with each other. Okay, and human brain will take the decision to solve the problem. So likewise, in artificial neural networks, we have input, we have nodes, we have weight, we have output. Okay, the cell nucleus in the brain is replaced by the neuron, and likewise some other medical terminologies like dendrites is replaced by inputs, synapse is replaced by weight, axon is replaced by output. The single unit of artificial neural network, this is the most important thing. If you would like to understand the convolution neural network, then we first should know the what do we mean by artificial neural network. So this is the basic structure of artificial neural network. So if you can find over here, this is your neuron, okay, and these all are the input x1, x2, x3, so on up to xm. Okay, so all these input nodes are connected with this single node via some weight. Okay, via some weight, and in this particular node, the summation will take place along with by adding some bias. So summation means x1w1 plus x2w2 plus x3w3, so on up to xmwm along with some bias. Okay, then after that, every node is having some activation function. Okay, so activation function is another terminology that we will discuss. So activation function basically activate the neuron. Okay, whether the output you need to fire or not based on certain condition. Okay, so there are different activation functions that we require, and finally you get the output. Okay, that is called as predicted output. This is called as predicted output. Actual output is different. Okay, so actual output is, say, suppose you are predicting the salary of per customer based on some parameter like age and year of experience. Okay, so this will become your age and this will become your year of experience. Okay, these two columns, these two features, and you are predicting the salary of person. Okay, and your model is predicting the salary as 90K. Okay, your model is predicting the salary as 90K, but the actual salary is of 1 lakh. Okay, so the difference over here it is of 10,000. Okay, so that difference is nothing but the error. That difference is nothing but the error, and we want to minimize this error. We wanted to minimize this error. Okay, so this is basically the single artificial neural network model, or you can say the simple perceptron model. So the structure of deep neural network is like this, where we have input layer, set of hidden layers, and output layers. Okay, and all these layers are interconnected with each other. You can see over here, it is a completely connected neural network. Completely connected means what? This is your layer 1, which is input layer. This is your hidden layer 1, hidden layer 2, and output layer. So you can find it over here that in every layer we have the node, set of nodes, and the nodes from each layer is connected with the other layer nodes. Okay, and each node is connected with every other node. So that's why this is called as fully connected neural network. Okay, so deep neural network means sometimes we can call it as a deep learning model also. Deep learning means, or deep neural network means what? There we have a more than one hidden layer. Input layer, set of hidden layer, and output layer. This is the structure of deep neural network. And in every layer, we have nodes. The terminologies that we used under the neural networks are the layers, activation functions, and weight. As we discussed, the layer, we know that the layers, we have three layers: input layer, hidden layer, and output layer. In every layer, you can find the different nodes. How it is different from the human brain? In human brain, there is no such a thing like layer. Okay, there are set of neurons, crores of neurons are there in our human brain. Okay, and all these neurons are interconnected with each other. This is basically a human brain, set of neurons that are interconnected with each other. But in artificial neural network, the structure is something different. Okay, we basically it is a mimic, or it is a copy of human brain. Okay, but some kind of differentiation should be there by adding the layers. So you can find one layer. Okay, in one layer there are nodes. You have the options that how many nodes that you want to add. Okay, so this is your input layer. Then set of hidden layer. Okay, so one hidden layer. So hidden layer 1, hidden layer 2, can add as many as hidden layer and add the nodes over there. And finally the output layer. Okay, so input layers, hidden layer, and output layer. These three layers you can find it into the neural network. Okay, all these nodes are interconnected with each other. Okay, so that is what we have already discussed. Now the weights, as I told you that the nodes are interconnected with other nodes via some weight. The importance of that weight is to reduce the loss or the error. So weight are the numeric value that are multiplied by the input, and via back propagation, in back they are modified to reduce the loss. So one example I have explained initially, that your model is predicting the salary as 90,000. Okay, but actual salary is of 100,000. Okay, and there is an error, or there is a loss of 10,000. Okay, and that loss, that error can be propagated in the neural model. Okay, and the weight is going to be adjusted, okay, by some optimization algorithm like Adam optimizer, RMS prop. Okay, so there are SGD. Okay, there are different set of optimization algorithm that are available in order to update the weights. Okay, and by updating these weights, neural model can reduce the error. Okay, this is what the purpose of weight. Okay, the weight factor is very, very important. Okay, one more time I'm explaining this thing. You can observe here, inputs are connected with other nodes, okay, via some weight. So you can find here each input is multiplied by weight 1, x1w1 plus x2w2 plus x3w3 plus xmwm. Okay, so this weight we are talking. Now next, activation function. So name itself indicate we are discussing the terminologies. The first terminology that we have discussed, it is a layer. Okay, then after that we have discussed the weight. Now we are discussing the activation function. Activation function, name itself indicate it is a kind of a door. Okay, like activating the neuron. Okay, so it is a mathematical formula that helps the neuron to switch on or off. Activation function decide whether a neuron should be activated or not. Okay, whether you want to fire the neuron or not, by calculating weighted sum and further adding bias with it. Okay, so if you see this deep neural model, on every node you can find, at every node, so you can find there is activation function. Okay, so that will basically useful for activating the neuron. Means what? Whether you want to fire some data through this node or through this node or through this node. Okay, so activation functions, we will add it into the different layer: input layer, hidden layer, and output layer. Okay, so different activation function, we use it for input layer, hidden layer, and output layer. Okay, so basically it is useful for forwarding the output. Sometime this node is not get fired. Sometimes this will not get fired. Okay, only this will, say suppose this node is not fired, only this. So kind of direction I will show you. Okay, like this. And basically this path will give us some output, final output. Now, so there are some activation functions that we have. The most popular activation functions that we have, the linear activation function, sigmoid activation function, sometimes we called it as a logistic activation function, ReLU activation function that we call as a rectified linear unit, and the final one is a softmax activation function. Okay, so these all are the most popular activation function. Now, I'm not going into the detail of mathematics as we have a limited time. So right now, those who don't know what activation function is to use, and if they don't know the mathematics, the simple thumb rule is that you can use the linear activation function and ReLU activation function. So basically, the simple linear is nowadays not useful. Okay, these three are useful. So you can use the ReLU activation function in the output layer. Okay, output layer. And sorry, not output layer, sorry. ReLU activation function in input layer and hidden layer. Okay, and sigmoid activation function and softmax activation function in output layer. Okay, so you can use sigmoid or softmax activation function in the output layer. So when your problem is a multi-class classification problem, then you can go for softmax activation function. When your problem is a binary class classification problem, then you can go for sigmoid activation function. Okay, binary classification means what? Say suppose I'm having one data set, and in that data set I'm having only cat and dog images, and we wanted to predict whether the image is cat or whether the image is dog. That problem is binary classification. Okay, so if it is the case, then in our output layer we add activation function as a sigmoid activation function. Okay, now let's take one example for multi-class classification. Multi-class classification means what? Say suppose I'm having one data set on which we are going to perform the implementation, CIFAR data set. There we have the 10 class of images. Okay, then that 10 class, okay, if it is a 10 class, okay, then in the output layer we need to add the softmax activation function. So simple thumb rule is that use sigmoid and softmax in the output layer. If it is binary classification, go with sigmoid. If it is multi-class classification, go with softmax. That's it. And other than output layer, without any hesitation, go with ReLU activation function. Okay, so that is the thumb rule. Now, the types of neural network that we have. Apart from that, there are several other neural network model. Okay, so the very basic model, it is a perceptron model. Then we have feed-forward artificial neural network, or you can say a multi-layer perceptron model. Then convolution neural network, on which our session is based. Okay, today we are going to discuss this convolution neural network. We have radial basic functional neural network. We have recurrent neural network. We have long short-term memory network that is called as LSTM. We have bi-LSTM. We have bi-GRU, GRU, sequence models. Okay, many other. But to all these neural networks, you should know this basic terminology which we have covered. Like we covered the layers, we covered activation function, we discussed the use of weight. Okay, so I hope up till now it is clear. Now we are going to start with the convolution neural network. So convolution neural network is a type of artificial neural network, and it is basically used for handling the image related projects. video related projects. So it is used in the image recognition and processing, which is specially designed for processing the data. So data that is nothing in the form of pixel. So you should also know about the image also. When we'll talk about the convolution neural network, okay, the main purpose of convolution neural network is to handle the image processing, computer vision related projects. Okay, so whenever we talked about the image, computer cannot understand the plain image. Every image is represented in the form of matrix. Okay, let me show you that thing, how it is. So you know this is apple, but computer not going to understand this is apple. Computer can only understand the matrix structure. Okay, and this image is represented in the form of number like 101, 10, 150, 30. Okay, so in the matrix we have the pixel intensity's value. Okay, pixel intensity. So for the image it is in the between 0 to 255. Okay, pixel intensity values, and that pixel intensity value is formulated in the matrix. Okay, for example, your image is of 32 by 32. Okay, then 32 by 32 matrix, 32 rows and 32 column, and in each particular cell you can find you'll have the intensity value. So computer can only understand the data in the form of matrix. Computer cannot understand this image. Okay, computer can only understand numbers. Okay, that is one thing that you should know. So in CNN, each input image will pass through the sequence of convolution layer along with the pooling with flattening and fully connected layer. Okay, so again, here is also the thing that we have the input layer, we have a set of hidden layer and the output layer. But along with that, in the hidden layer, we have some other layers like convolution layer, max pooling layer, flattening layer. Okay, so that we will discuss in detail. So with this diagram also, you can find it over here. This is a kind of image recognition project where we have data. Okay, and this is a classified image. Okay, so this image is as an input to the model, and your model is going to be predict to which category it fall. Okay, so that image is taken from the camera, certain pre-processing operation has done. Okay, so these are the basic steps: the collection, data collection, then do some pre-processing. Okay, so there is a life cycle. Okay, that also we will discuss. Okay, when we go for the implementation part, I will show you what are the generalized steps that is to be required. Now, steps to design the CNN model. Okay, so how can we design the CNN model? As I explained, the neural model contains the three things, the layers. Okay, the input layer, then hidden layer, set of hidden layers, and the output layer. So now here it is as a part of hidden layer. Okay, we will add these layers like convolution layer we are going to add first, then we are going to add max pooling layer, then the flattening layer we are going to add, and then finally the fully connection. Full connection means your ANN model. Okay, so these are the 4 steps that we need to add while creating the CNN model. So convolution layer, the step 1 is a convolution. So convolution, it is a kind of the multiplication operation. Okay, so but with some different way. So convolution layer is the first layer to extract the valuable features from an input image. Okay, so the purpose of this layer is to extract the important feature. So if you go with the basic ANN model, okay, if you go with the basic ANN model, then it will be very computationally expensive, because in ANN model we give complete image to your model. Okay, and your model is processed on complete image. Okay, but that is not the requirement. That is not the requirement means what? We need some basic information, important information. Okay, so feature extraction is one of the important tasks in AI. Okay, on the extracted feature, valuable extracted feature, we are going to train the model. Okay, and that is the first task of the convolution layer. So convolution layer has a several filters that perform the convolution operation. Several different filters are there. It is a mathematical operations which takes two input such as image matrix. Okay, as I told you, image is represented in the form of matrix, and there is a kernel or filter. Okay, let me show you what it exactly. So basically, if this is my image, okay, image is of size, this is height of the image, this is width of the image, and this is the depth. Okay, so and this is a filter. Okay, so multiplication convolution is done by image multiplied by or image convoluted by filter, and you get the convoluted feature map. Convoluted feature map means it is a extracted valuable feature. Okay, and you can see over here your size of the image is get reduced. Okay, as I told you, it is computationally expensive if you give the image as it is. Okay, and that will be very expensive. Okay, lot many iterations will take place whenever we go for training the deep learning model. So we want to reduce the dimension also. Okay, so if you can find it over here, this is my input image of size 8, 1, 2, 3, 4, 5, 6, 7. Okay, so the size of this, it is 7 by 7. Okay, 7 by 7 input image, and this is the sample filter. Okay, and the convolution is done. Okay, convolution is done like this. Okay, so where there is a 1, okay, you need to multiply the convolution. Okay, so you can find over here 0 multiplied by 0. Okay, 0 multiplied by 0. So there is no match, that's why we have 0 at this place. Okay, then let me go for other one. Now you can see over here 0 0, then this 0 with this 0, this 0 with 1. Okay, 0. Now you can find here 1 multiplied by 1. Okay, 1 multiplied by 1, it is 1. So that's why you can find 1 over here. Okay, if say suppose here also there is a 1 and here also there is a 1, then you can find the 2 over here. Okay, similarly, if you have 1 over here, 1 over here, then this value become 4. Okay, this is a kind of convolution. I hope it is clear. So after that, after doing the convolution, you can find the size of the image is now get reduced to the 5 by 5. This is the size of 3 by 3. Okay, size of filter. Now this is my reduced image, and this is kind of valuable information. Okay, valuable extracted features that we have. Okay, and we get several such features. Okay, you can find over here by doing the convolution with different filters. Okay, so different filters, some filters related with the contrast, some filter related with the age, some filter is related with the brightness. Okay, so there are lot many filters available. Okay, and you get the set of feature map. Okay, so basically the purpose of this convolution is to extract the valuable features and reduce the dimension of the image. Okay, so this is the convolution operation. Then second step is the max pooling. Max pooling is the second step. Okay, the max pooling layer we need to add. So this layer is also important in pre-processing of the image. So the main purpose of this max pooling layer is to reduce the dimension without losing the important features or pattern. Okay, so you can find it over here. So max pooling layer basically interested in the fixed the specific part. Okay, and with the help of this max pooling layer, we can reduce the image dimensionality. Okay, let me show you how it get reduced. So for example, I'm having this matrix. Okay, matrix means your image. Now you know that this is your 4 by 4 image. Okay, now if I'm going to use the max pooling Okay, if I'm going with the max filter. Okay, so this is one max filter. Okay, so now you can observe the max. If we pass this image, through max pooling, then it will like this. So basically 2 by 2, if we are going with the 2 by 2 max pool filter, then it will choose the maximum element. The maximum element among this 2 by 2 matrix is 20. Then maximum element from this, it is 30. So we'll add 30. The maximum element from this, it is 112. Okay, maximum element from this, it is 372, or sorry, it is 37. Okay, so this is your reduced image. Okay, so 4 by 4 image is now get converted into the 2 by 2. So the purpose of max pooling is to reduce the dimension without losing the important feature. So initially, if you can say, if your image is of 7 by 7, okay, then after that it get reduced to the 5 by 5. So if you pass it to the max pooling, then it may be reduced with the 2 by 2 also. Okay, so that is how the features is get reduced. Okay, dimension is reduced. Okay, so you can find it over here also. So now this is your input image, convolution stage. So convolution stage, again you get the convoluted feature map with reduced dimension. Then in max pooling layer, you again get the reduced feature map. Okay, this image is also get reduced because of the max pooling layer. Now the final one, sorry, not final one, the step third, that is flattening layer. Flattening layer means it is basically create the vector form of the matrix. Okay, so for example, if it is the featured pool map, one of the featured pool map, it is one matrix. Okay, so with flattening, we convert this matrix into the one vector. Okay, so you can find here 1 1 0 1 1 0, then 4 2 1 4 2 1, then 0 2 1 0 2 1. Okay, so this is my flattened vector. So each, so there are lot many pooled feature map. There are lot many feature map, and this each flattened will become your node now in the next step. So you can find here. So there are pooling, there are lot many pooled feature map. Okay, and after going through the flattening layer, okay, you will get one vector, and this one vector become your one node. Okay, and that we will give it to the your ANN, that is fully connected neural network model. Okay, so next step is this is the flattening structure. Okay, input image, convolution layer, pooling layer. After flattening, every matrix, okay, every feature matrix. One more time, I'm explaining. After the pooling layer, say suppose there is 1 2 3 4 5 6 0 2 1. Okay, this is my matrix 3 by 3. So this will become your one vector, where we have 1 2 3 4 5 6 and 6 to 1, like this. One complete vector in one node. Okay, this will become your node of artificial neural network. Then the fully connection. Okay, this is a full connection. So full connection layer, that is your last, known as a dense layer, in which the result of convolution are fed through one or more neural layer to generate the final prediction. Okay, so now after flattening, the data is going with the fully connected neural model. Okay, in fully connected neural model, you can see over here input layer, then your hidden layer and output layer. So now this is a kind of full connection. So let me directly show you the overall summarization. So in overall summarization of the CNN steps, you can find over here, input image is get passed through the convolution layer. Okay, you will get the convoluted feature map. Then it passed to the pooling layer. You will get the pooled feature map. Then the flattening is performed. Flattening means the pooled feature map converted into the vector, and that give it to the fully connected neural model. Okay, this is your fully connected neural model, and from here you will get the prediction. Okay, so like which one it is. For example, if it is a dog image, okay, so at the final node you are getting dog is equal to 0.95 and cat is equal to 0.05. That means 95%. Okay, so 95% means you can say my model is predicting that this image is related to the dog. Okay, then second case, if it is a cat image, you can see over here the dog is having the percentage 21 and cat is having the percentage of 79, and your model can predict that this image is a cat image. Okay, so this is a overall summarization. Okay, I hope this is clear. So to implement the CNN, you need to add convolution layer, you need to add pooling layer, you need to add flattening layer, and then finally dense layer. Okay, to dense layer means it is a fully connected neural model. Okay, now we are going for the implementation part. Okay, so the case study that we are considering over here, we are creating one model, convolution neural network model for image recognition, and we have one data set. That data set is nothing but the CIFAR. Okay, so that basically a Canadian institute, the related data set. Okay, that is created by the Canadian Institute. Okay, so CIFAR data set includes 60,000 images. Okay, of size 32 by 32. Okay, all are color images. 32 by 32 means the 32, you can say the matrix size become 32 rows and 32 columns in 10 classes. Okay, in 10 classes with 6,000 image per class. Okay, there are 50,000 training images and 10,000 test images in the official data, and the label of the classes are include airplane, automobile image, bird, cat, deer, dog, frog, horse, sheep, and truck. So this is how it looks. So in our data set, we have these things, airplanes, okay, all the images, okay, 6,000, 6K. Okay, so total there are 10 categories. So total 60,000 images are there. So whenever you want to work with the image related case studies or video related case study, okay, and you want to create the deep learning model, then you need a data set. Okay, and that data contain lot many images. It is not the case that you are creating the model with 100 images. Okay, so that model is not of any use until and unless you have the huge amount of data. You cannot go for the model creation. Okay, so you need as much as data. Okay, although there are some ways. Okay, say suppose you are having 10,000 images. Okay, although we are having a way, like you can go with the data augmentation approach. With data augmentation, you can increase the size of your images, okay, by rotating. Okay, so for 10,000 images, you can go with the 40,000 also by applying the data augmentation. Okay, applying the data augmentation means you can rotate the image. Okay, you can blur some image, perform some operation, and create uh, the image on your own. Okay, so this is our data set on which we are going for creating the CNN model. Okay, now let me show you the how to download the data set. Okay, so this is a page where you will get all the information about the data set. Okay, so all information about the data set, you can get it from this link. Okay, now for this case study, what we are going, so for this case study, so we are following these things. So this, if it is my input image, we will go for adding the convolution layer first, then pooling layer. Okay, it is up to you how many convolution layer and how many pooling layer that you want to add. So when we say the deep convolution layer, deep convolution neural network, deep means what? We are adding more than one convolution layer and pooling layer. So I'm going to add the another convolution layer and another pooling layer. Okay, so that means this is a pair of convolution layer and pooling layer, another pair of convolution layer and pooling layer. You can add as many. It is based on your uh, problem statement. Okay, how much accuracy that you want and what system do you have. Okay, if you are having a good system that is having good GPU and all, then you can add some more convolution layer and pooling layer. Okay, by adding this, your model is get trained properly. Then flattening layer, and it is a dense layer, and finally we get the output. Okay, so these are basically the steps. So let me show you. So first is the input. Then we are going for adding the convolution layer, pooling layer, then flattening layer, then output layer or dense layer. Okay, so you can add convolution layer and pooling layer. It is up to you how many that you want. Convolution layer 1, pooling layer 1, then convolution layer 2, and pooling layer 2. Okay, so final structure become like this when we implement our model. Now, these are the steps. Okay, these are the generalized steps that are involved in any implementation that is related with the artificial intelligence, deep learning, or machine learning project. The very first step is identify the problem. Okay, as I told you, why we are discussing this neural network, deep learning, and all, the purpose is to solve the problem, real world problem. So now we have identified that I want to recognize the image. Okay, that is what my problem statement. Your problem statement may be different. Okay, if someone is working with some .csv data set, Excel file data set, numerical value, they may go for the medical related problem. Medical related problem means heart disease prediction, breast cancer prediction, okay, diabetic prediction. So there are different set of problems in the real world. Okay, so almost in every industry, you can find the use of this AI, like medical, then your pharma, then manufacturing, e-commerce, agriculture, weather forecasting. You can take any name where you can fit the artificial intelligence. And we want to make the automated model that can solve the problem. So identification of the problem is the first stage. Sorry. Based on the identified problem, we go for collecting the data. Say suppose we have identified that I want to go with the image recognition. So I will go for collecting the image related data. Say someone is working with the heart disease related problem. They go for collecting the heart disease related data by visiting the hospital, by collecting the data from the hospital, by visiting the university website. Okay, there are different ways. You can go with the Google dataset search engine to collect the data. So data collection, different sources, via different sources, you can create the data. So if it is an image related thing, okay, then you can create your own data set also. Okay, you can create your own data set and store it in your system. That is also the way. Then third step is data pre-processing. Data pre-processing, you know that whenever we collect the data from the real world, that data is not a clean data. Okay, so you need to clean that data, you need to pre-process that data, you need to convert the raw data to the clean data. And there are many things like the image may contain the noise. Okay, image is not in the proper format. If it is a CSV related data, then there will be a missing value, there will be a categorical data, there will be a redundant data, duplication is there. So lot many stages are involved. Again, feature scaling is also one of the important thing that we need. Scale everything into one single scale. Okay, so this is a part of pre-processing. Okay, so pre-processing is one of the important stages in the any implementation. Then we go for selecting the deep learning algorithm. Okay, selecting the deep learning algorithm as per our need. Someone may use the ANN, someone go with the CNN, someone go with the LSTM, RNN. That is based on the problem statement. Okay, if it is a problem that is related with the sentiment analysis from the text. Okay, then problem identification, data collection, pre-processing. Okay, then selecting the deep learning algorithm means it is LSTM or RNN. If it is image related, like in our case it is, then we are selecting the CNN, or we can go with some advanced algorithm also that is based on the CNN, VGG16, VGG19, ResNet, then GoogleNet, AlexNet, okay, all Inception. Okay, there are a lot many transfer learning models also. And all these models are based on the convolution neural network. So selecting the deep learning algorithm is the fourth stage. After selecting, we go for training the model. We train the model on training data set. Okay. And then we go for testing the model. Once the model is ready, okay, let me show you. Say suppose this is my CNN model. Okay, CNN model means there are many layers: convolution layer, pooling layer, flattening layer, and fully connected layer. All these are interconnected. Okay, so we give the data, training data to this, and your model is going to be trained like this, learning the things. Once it get ready, okay, once it get trained, then we go for testing. Testing means we give some image. Okay, we will give some airplane image to this model and we'll test it whether my model is giving the correct output or not. I'm giving the airplane image and my model is also giving that it is a airplane. Okay, so like this is the kind of testing. Okay, we are testing it. Evaluate the performance. Okay, so evaluate the performance, we have certain metrics: accuracy, precision, recalls. Okay, by this we can evaluate the performance. Performance means what? For example, I'm giving the airplane image and the model is going to be recognized as a cat. Okay, so airplane is my input and cat is my output. Okay, that means my model is not working properly. It is not trained properly. Okay, so my performance is not good. Okay, so that's why we need to evaluate the performance also. Okay, so after that, okay, once we get to know that my model is performing fine, okay, I'm passing airplane image and getting airplane image. I'm passing cat image, getting the cat as output. Okay, that means I'm getting the good performance. Then the final step is the deployment, that you can use this model in the real world now. Okay, because the performance is good. Okay, so these are the 8 stages that are involved in any implementation. Problem identification, identify the problem. Based on the identified problem, go for the data collection, perform the data pre-processing, select the deep learning model, train the model, test the model, evaluate the performance, and deployment. Okay, now, next. Now, to build the CNN model, we will go with this. We first define the network. Okay, this is important because now we are going for the implementation. So when we go for creating this model, we first define the network. We will add the different set of layers: convolution layer, max pooling layer, flattening layer, dense layer, and then we compile the network. Define the network means adding the layer along with the nodes. Okay, along with the nodes, how many nodes that we want in one single layer. And compile the network means connect all, and then go for fit the network. Fit the network means train the model, then evaluate the performance by testing it and go for the prediction. Okay, this is how we can go. Okay, now let's go for the implementation part. So to implement this, I'm going to use the Google Colab. Okay, Google Colab is the online platform that you can use to work with the deep learning, machine learning related things. Okay, so it is an online platform. So automatically it get opened with your Gmail ID, Google ID. Okay, so I'm going to create the new notebook. I hope most of you are aware about this thing. Okay, it is a kind of Jupyter notebook structure. Those who are having a good system, okay, they can use the offline platform also via Anaconda, okay, and go with the Jupyter notebook. Okay, now, so this is our CNN 10/10/2022. Now, the very first thing that we need to import the library. Okay, so I'm going to import the necessary library. So as we are dealing with the images, so you need matplotlib library. Matplotlib is the library that is related with the data visualization. So that's why I need this one, matplotlib.pyplot as PLT. This is the first library. Then I need TensorFlow. Okay, TensorFlow, it's basically it is a heart of deep learning. Okay, so TensorFlow, Keras, PyTorch. Okay, these are the deep learning related libraries. Okay, and I'm going with the TensorFlow and Keras. So from TensorFlow.Keras, I'm going to import the data set. Okay, so the data set that I'm talking it right now, the data set is already available in our TensorFlow library. Okay, so that's why I'm importing the TensorFlow.Keras and importing the data set. Okay, and we are going to take the use of CIFAR data set where we have the 10 categories of the images. Okay, that we have already discussed with you: airplane, automobile, bird, cat, deer, dog, so on, so on, so on. Okay, so it is loading. The next is download the data set. Okay, so to download the data set, you need to store this data set into the splitted manner. Okay, the splitting. So here directly I'm going for the splitting because you need to divide the data set into the train and test. Train part is used for creating the model. Test part is used for testing the model. Okay, so I'm writing here train, comma. So you can write here the train images, comma, train label. Okay, train img, train underscore lab, label, comma. Second category, second dividation, test images, comma, test label equal to datasets dot CIFAR. This is our data set. Okay, you'll get the hint also. There are two, CIFAR 10. I'm going with this, and load data is the method. Okay, load data and enter. So it will take some time to download the data set. 21, 30, 11 seconds, 9 seconds, 7 seconds, 5, 4, 3, 2, 0. Okay, done. Downloading. So directly we have taken the data set and we have divided the data set into the 4 parts: train image, train label, test image, test label. Okay, all these are the label data set. Label data set means it is a kind of supervised learning problem. Okay, so now let us go for normalizing the image first. Okay, so I'm going with the normalization. Okay, that comes under the data pre-processing. I'm going to normalize the pixel value. Normalization of pixel value in the range of 0 to 1. Okay, so right now the pixel intensities is in between 0 to 255. Some value is 0, some value is 1, some value is 10, some value is 233. I'm going to normalize everything into 0 to 1. Okay, so let me copy this, equal to, okay, train image divided by 255, comma, test image Let me take the test image. Okay, so test image and divided by 255.0 and execute. Okay, so this is the normalize. Let me show you the 10 images, 10 image class. Okay, so the class name, I'm going to create one list. Let me copy it from here. Okay, let me. Okay, I'm creating the list. List of all the categories and pasting it over here. Okay, so these are the class name, and then setting the plt.figure and peak size is 15, 15. Then for I in range, so I want to show you the first 10 image of this data set. Okay, so that's why I'm passing the 10 over here. And in subplot, I'm going to show you. plt.xtick plt.imshow, and in that there is a train image in bracket I plt.xlabel this is class name in bracket train underscore label. And plt.show. Mat has no attribute figure, so let me check. It is figure. It is label. Okay, so these are the first 10 images, frog, truck, deer, okay, in the data set, from the data set. Okay, now I'm going for initializing the CNN model now. Initializing or creating the CNN model. So to create the CNN model, the very first thing you have to import the sequential class. So keras.model, we need to import sequential. This is the name of the class. I'm going to create the object, and this is our model. And in the model, we are going to add the different layer. Okay, so this is, okay, let me check models. So we have initialized the ANN model. Okay, so this is the initialization of the model. Okay, then in this model, we are going to add the different layer. Okay, so one by one, I'm going to add the different layer. Okay, as we have the time constraint, so let me open the existing collab file. Okay, so that we can proceed faster. Okay, so let me open it. Now I'm going to copy one by one. I'm adding the layer. Okay, so after initializing the CNN model, then I'm going to create the convolution layer. So let me copy this. Okay, so convolution layer, the step one which we have discussed. Okay, you need to add the, let me change the object. Okay, so this is classifier is my object now. Okay, you can take any name. Now this is the first layer which I am adding by the help of dot add, classifier dot add, convolution 2D, 32 neurons I am adding. Okay, 32. The size of the filter is 3 by 3. Then input shape. Okay, the size of the image is 32, 32 and 3. Okay, if you can check the size of the image. It is a color image having a size 32 cross 32 cross 3. Activation function is relu, which I have already explained that if it is other than output layer, then every time we go with the activation function as relu. This is my first layer, convolution layer. Okay, now let me add another layer. So pooling layer I am adding now. Okay, so pooling layer is the step 2. Okay, so classifier dot add, the name of the layer is max pooling, and I'm specifying the pooling size. The pooling size is 2 cross 2. Okay, and execute. So with which we have added the pooling layer. Okay, as I told you, I'm going with adding the second convolution layer and second pooling layer. Okay, so I'm adding the second convolution layer and second pooling layer. Okay, so this is my another convolution layer and another max pooling layer. So in convolution 2D layer, you can find over here 32, the number of input nodes, size of the filter, it is 3 by 3, activation function as relu. Okay, so this is our structure that we are following. Okay, let me show you one more time. Okay, convolution layer we have added, pooling layer we have added, again convolution layer we have added, again pooling layer we have added. Okay, now it is a turn to add the flattening layer. Okay, so let me add the flattening layer. So I'm copying it from here, flattening layer. Okay, copying it and pasting it. Okay, and execute. Okay, so this is my third step, adding the flattening layer. Now, the next step is create the full connection. Okay, so full connection means it is a dense layer. So let me copy the dense layer code or full connection code. So to add this, I'm going to add full connection over here. Now you can see over here, the first layer that I'm adding having activation function relu, and this is our final layer. Now you can observe activation function I have specified over here as a softmax, and number of unit in the output layer I have specified as 10. Why 10? Because there are 10 categories. Okay, that's why 10 nodes we have specified. Activation function I have used, it is softmax only because that it is a multi-class classification problem. Okay, other than that, we have used the relu activation function. You can see over here, everywhere we have used the relu. Okay, I hope this part is clear. Now this is your full connection. Okay, now this is your full connection. Now next is your summary of the model. Okay, let me show you the summary. Okay, this is very interesting. In research paper, in many article, you can find this thing, the summary. Okay, these many layers are there in my CNN model. So you can see over here in my model, There are convolution layer, max pooling layer, again convolution layer, again max pooling layer, flatten layer, dense layer, and final output layer. Okay, so this is the structure that we have followed. Okay, in our implementation, you can add as many as layer as per your need. Okay, you can add n number of, you can do n number of changes. Okay, so here I have used, basically what we have used over here, this is your convolution layer, max pooling layer. Okay, the same structured over here, convolution, max pooling. This is our flattening layer, which is our step 3, dense layer. Okay, so in dense layer, this is our normal hidden layer, and this dense layer is our output layer. Okay, so this is the summary. Also, you can print the diagrammatic representation also. So let me show you how to represent the diagrammatic representation. Keras dot utils dot vis underscore util import plot underscore model, and then create the object of plot underscore model, pass the classifier. This classifier I'm passing, and write the to underscore file and our model CNN model dot png. Okay, keras dot utils execute. Now you can check, see over here, this is what the CNN model that we have now. Convolution layer we have, okay, max pooling layer, convolution layer, max pooling layer, flatten layer, dense layer. Okay, so this is my deep convolution neural network. Okay, where we have added the 2 convolution layer, 2 max pooling layer, 1 flattening layer, 1 dense layer, 1 output dense layer. Okay, so with this line of code, you can print the structure of your model. Okay, diagrammatic representation of the model. Now, next is you can go for compilation of the model. Okay, now you need to compile the model. Compile the model. So we don't have the time to write the code. That's why I'm copying it from over here. So compile the model. So let me copy this code and place it over here. So here we are using the optimizer as Adam. Okay, there are different optimizers, RMS prop, then you can use the SGD. Okay, it is for adjusting the weight. Then the loss is equal to categorical cross entropy. Okay, if it is a multi-class classification problem, and matrix that we are considering, it is as accuracy. So basic the role of compilation over here, it what, just to connect all the layers with each other. Right now we have added the layers. Okay, you can see there are lot many layers that we have, but these layers are not connected. Okay, there are many layers in our model, but these layers are not connected with each other. Okay, so no, so to connect this, we use the compile. Word compile means connect all the layers with other layers by adding the weight and everything to create the dense model. Okay, so this is called as compilation. I hope compilation is clear. Now let me execute this, compile the model. Okay, after compiling the model, we go for the model training. Okay, so model training, I'm going to use the dot fit method to train the model, where we can add the epoch. Okay, so it will take the time. Okay, so if you want to train the good model, you can increase the epoch. Epoch 10 means the 10 iteration, epoch 100 means 100 iteration. Okay, so basically in every iteration the model get learn the things. Like our human brain is also like this. Okay, when we go for the some exam, we read something one time, two times, three times. When we read it for 10 times, then it will get remembered by your brain. Okay, the same thing is happen in the neural model also. Okay, train image. Okay, let me change the img. Okay, img. Test label. Okay, let me check the name. In our case, the variable names are different. That's why we are getting the error. In our case, test labels, labels, labels. Okay. Now it will take some time. Okay. So this is how the epoch is. Okay. So in every epoch, you will get some loss accuracy. Now I will show you this in the other Jupyter notebook because we don't have the time to train the model. So already I have trained that model. So you can see over here, accuracy is get increased in the iteration. So in the first iteration, you can find this 45% accuracy. Then it will get increased in every iteration. Okay, so you can try with 100 epoches. Okay, and you'll get the good accuracy. Okay, more than 85 also. Okay, so after training the model, our next step is to check the performance by plotting the graph. Okay, so this is a plot where accuracy versus epoches. You can see over here, epoch increases, accuracy is also increases. Okay, epoch increases, accuracy is also, epoch means the iteration. Then finally, we get to know that my model is working fine. I'm getting the more than 75% accuracy, 85% accuracy. Then you can go for testing the model. Okay, so here is the code to test the model, to go for the prediction. Okay, after evaluating the performance, we are going for the prediction. So here we are passing one image. Okay, and our model is predicting that this image is related with the automobile. Similarly, again, we are passing the images, okay, set of images, and my model is going to predict the which image it is. Okay, so now my model is ready. You can pass any image. You can download the image from the Google, scale down to the 32 by 32 and give it to your model. Your model is now capable that whether that image is related with the airplane, or whether that image is related with the automobile, bird, cat, dog, deer, anything. Okay, so this is the thing from my side. Okay, this is how we have implemented the CNN model. I hope it is clear. So any questions, anything? So CNN model implementation is done over here. Any doubts so far, participants? I hope everything is clear. Okay, let me explain one more time. First, import the library, go for data set, then normalize the pixel value in the range of 0 to 1. Then this is how you can display the first 10 images of your data set. Then go for initializing the ANN model, add the convolution layer, add the pooling layer, another set of convolution layer and pooling layer, flattening layer, fully connection layer. Okay. After that, you can check the summary. Then you can print the diagrammatic view of your model. Okay. But this model is not a compiled model. Okay. That step is very, very important. Compilation means connecting all the layer with other layer. Okay. Optimizer, loss, matrix, we are going to add it. Okay, Adam optimizer is basically use it for weight. Okay, that weight we are talking, that weight is get updated in the neural model. Okay, to reduce the loss, and that thing is taken care by this Adam. Okay, then history. Okay, so this is what my fitting dot with the dot fit method. You can train the model on training data set. Okay, this is the evaluate. This is for evaluating the performance and for the finally prediction. Now you can go for the deployment. Okay, so in this way, uh, we have completed with this CNN, Convolution Neural Network. I hope it is clear. As I know, lot many things are there. With 1 hour, it is not possible to explain everything, but I tried my best to explain everything. Okay. Yes. Any questions?
Yeah, we do have queries in Q&A section, but considering the time, you can like answer them in a quick jiffy. That would be great.
Okay.
And along with that, users are being like have asked for the PPT and the
Yes.
code and the code you wrote.
Definitely, we will share the PPT. Okay, I will share the PPT and the code. Okay, whatever I'm having along with the data set also. Don't worry about that part. Okay, so most of the questions are related with this. Okay, Google Colab, PPT, notebook link, please. Yes, we will share it. Yes, can we use the one convolution 2D layer? Yes, you can use one convolution layer and one pooling layer. It is up to you. Okay, you can use two convolution layer, three convolution layer also. Okay, so that is basically related with how deep you want to make your model. Okay. Then ReLU functions move from 0 to any number. We are extracting the important features. So negative numbers are not valuable. Thus, they are not tuned to 0 when passed through the ReLU activation, and any positive number remain intact. Okay, so basically, ReLU functions, that is a functionality of ReLU. So here it is, we are extracting the important features. Okay, and most of the features are not negative in that case. Okay, when we are talking in the images, slightly we have one thing, that is related with the leaky ReLU. Okay, if something goes beyond the zero, something beyond the zero, you can go with the leaky ReLU. Okay, but ReLU is also best. Okay. Why we didn't use the ReLU in output layer? That's what I explained in the initial itself. Okay, that ReLU is basically for the other than output layer, because we don't get the output in the appropriate format. For example, if you know the sigmoid activation function, let me show you. If you know the sigmoid activation function, okay, so sigmoid is one activation function. It is a S-shape activation function. Okay, it is a S-shape activation function like this. And the value that we get is in the range of 0 to 1. So if your model is predicting the value, here certain threshold of 0.5 is fixed. If the value is goes beyond 0.5, then it will be categorized as 0. Okay, so that's why it is useful for the binary classification. If it is above 0.5, then it will be categorized as 1. Okay, so this is for the binary classification. Okay, so binary classification, we go with this. Whereas in multi-class classification, we go with the softmax activation function. Okay, and ReLU is having the graph like this. Okay, this is the graph. For leaky ReLU, which I talked about the negative number, it will be goes like this. Okay, I think most of the questions. Yes, YOLO in the next data hour. Yes, YOLO is also one model, that is a transfer learning model. Yes. Do we have time to answer other questions?
Yeah, if you are okay with that, but we can be like in a quick jiffy, you know.
Yes. So when talking about the weights, don't we have the backward propagation? Yes, we have the backward propagation inbuilt when we are going for this implementation. Okay, we have the one line of code to compile the model, but internally they are using the backward propagation. Backward propagation means it will back propagate the error. Okay, the error is back propagated in your neural network. Okay, and based on that error, your weight is going to be updated. Okay, weight is going to be updated, and that error is get reduced. Okay, and that is the purpose of Adam optimizer. Okay, so this is related with the backward propagation. Yeah, validation, that is validation means it is some part of our trained data set that we are going for the validation. Testing means the one separate part that we are creating. Okay, so you can create the three parts: training, validation, and testing. Yeah, same questions. First dense layer. Explain the use of ReLU over Sigmoid and softmax. I think already I have explained Sigmoid softmax are useful in the output layer. Okay, and ReLU activation function is useful in the other than output layer. Okay, so that for that we need to go in some mathematical terms or the graphs and mathematics behind this. Okay, somewhere down the line I have explained the sigmoid curve. Okay, the sigmoid equation is also there. P is equal to 1 upon 1 plus e raised to the power minus x. Okay, so this is the equation of that sigmoid curve. Activation function must be same within a single layer but cannot be different across the different layer. So based on your model, okay, if you are adding one hidden layer, okay, then go with ReLU. If you are adding another hidden layer, then also you go with the ReLU activation function. So it is not the case that you cannot go with the different activation function in the different layer. Okay, so different layers you can add the different activation function. I think most of the questions are covered. Okay. Yes. So here is something and some note is given by David, the vanishing gradient problem. Okay. So again, these are some problems. Okay. In depth, we need some time. Okay. So in single lecture it is not possible to cover all these things. Okay, what is gradient problem, vanishing gradient problem, and how we can use it. Okay, so if you want to use it, you can go for the leaky ReLU. Okay, here is mentioned leaky ReLU. Yes, I think done from my side.
So, all right. Thanks a lot, Nitin. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. And guys, whoever are left with their questions from Q&A section and stuff, considering the time constraints that we are already almost took 20-25 minutes more, still we are left with it. That means we need to give more time to the session and to the topic. So probably we will be doing that in the next session. And I would like to launch a feedback poll for you guys to drop your feedbacks regarding the DataHour and the speaker. So do put in your opinion in the polls. Just a second. Also, I will be sharing Nitin's LinkedIn profile where you can connect with him. And if you guys are having any issues or queries, you can clear it out if he's available. I just launched a poll. Do interact to the poll, guys. Also, a link to Nitin's LinkedIn profile is in the chat section. You guys can pick it up from there. And you will and you guys will also be getting links for upcoming sessions there. You guys can register yourselves and get the seats done. So yeah, thank you, Nitin. Thank you. Really, thank you very much for your time and for delivering such a wonderful session. And I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in future.
Thank you, participants. Yeah, bye-bye.